Hey gang, so let's do our exponential function Freyer. So we're just going to go over this and recap everything. So you've got the equation f of x equals a times b to the x power. So let's just remember that a, we did that as the starting amount. That was how much we started with. It was also our y-intercept. Okay, it was our y-intercept as well. Our b, remember that was the common ratio. Now remember, when you use the common ratio, that's where you take the second term and divide it by the first term. And we did that when we did our geometric sequences. The couple of rules for b, remember, it can't be 1, it can't be 0, and it has to be positive. So b cannot be 1, it cannot be 0, and it has to be positive. Remember, I kept saying it has to be happy. Don't worry, be happy. Okay, let's do a couple of pictures. All right, let's put some graphs on here. Let's do a growing graph, a graph that is growing. And when you think about the word growing, you think about something getting bigger, so it's increasing. So this is going to be growing and increasing. And then we'll do this other graph over here. I'll do it in green. And we're going to call this a decaying graph. And when you think about decaying, think about decreasing, getting smaller. Decaying will be decreasing. All right. So the obvious growing one is when it goes up like this. That's obvious. You're like, oh yeah, if I read from the left to the right, that's getting bigger and bigger. The one that's not so obvious is when it grows negatively. So it's still starting small, but it's growing more and more negative. I think about it like if you owed money to somebody and you have to owe them more and more and more and more, and pretty soon you owe them a whole bunch of money. So these are both growing. Decaying, read from the left to the right. You start tall, you start big, and you decay down to nothing. You decay down to something small. Or maybe you start by owing somebody a whole bunch of money, and by the end, you owe them very little. So these are both decaying or decreasing, increasing and decreasing. Read from the left to the right. What are the y values doing? These are getting smaller. These are both getting bigger. All right. I think that's pretty much all I want to say on that. I do want to just remind you that we also looked at f of x equals a times b to the x power, and we did plus k. And I just kind of reminded you, and you won't really see this until Algebra 2, but it is handy to know now. K represents the asymptote. On ours, up here, the asymptote would be 0. The asymptote is the line that you touched, or that you try to touch, and you get really, really close to it, but you never, ever reach it. And remember that the word asymptote has the y in it, and so the equation is y equals something, because the word asymptote has the y in it. All right, so that was kind of in a nutshell what we did there. So let's just take a second and let's just graph it. Let's talk about the characteristics of the graph. So here's my graph, 5 times 1/4 to the x power. Let's see. When I'm just going to plug that in. Oh, I don't even have to. I've already got a graph of it. So here's the graph. So let's look at a couple of things. The starting amount is 5, which is right here. So I could say that a equals 5. The b value is 1/4. Something we haven't really talked about much in my class is if b is between 0 and 1, it's a decreasing graph. So if b, let's do it this. If b is between 0 and 1, then it's a decreasing graph, which this is going down, so it's decreasing. But if b is greater than 1, it's a growing graph or an increasing graph. Okay, those are just some things right there that, you know, you might put those somewhere on your paper. Those are just some fun facts. You can always throw it in your calculator and graph it and you'll be fine. Okay, let's talk about the domain. Let's label all of our infinities. When you go this way, it's positive infinity. If you go up for forever, that's positive infinity. If you go down, that's negative infinity. And if you go this way, that's negative infinity. Okay. I can see the boundary right here. I know that on this, it'd be plus 0. So I see my asymptote is y equals, and there's nothing there, so it's 0. Or I can look right here. I can get my highlighter out because y'all know I like to highlight those asymptotes. Oops. There's the line that it's getting really, really close to, but it doesn't touch. Remember, it doesn't actually touch it. Even though your calculator shows, it reaches it. You'll get to that in calculus. All right, so the domain, how wide is it? Well, it goes forever and ever this way and forever and ever this way. The graph is going to keep going. There's no boundaries, so I'm just going to say it's all real numbers. I could do the negative infinity less than x less than positive infinity if I wanted to. Whatever you want to put, I'm just going to put all real numbers. How tall is it? So the range is how tall. Well, I see there's a floor right here, and the graph doesn't go below it. It's all up here. So my low number that it's getting really close to is 0, and the high number that it's going up to is infinity. So 0 less than y, because it's the range, it's not the x, less than positive infinity. And then remember we talked about if you have a number on one side and infinity on the other, you can kind of leave the infinity side off. So I'm going to do this. I'm going to actually just mark that off. And I would say 0 is less than y. But remember, we like to read with the y first. So we're going to put y and 0. It's opening to the y, so we're just going to turn it around to the y that way. So there's my range. There's my domain. The y-intercept I can see is right there at 0, 5. And those are the characteristics. You could get all those just by graphing it if you needed to, and it would work out there too. All right, so let's go down here and let's graph some exponential functions. So I'm going to give you a couple. The first one I'm going to give you is y equals 2 to the 3x power. And this one's going to be y equals negative 2 to the 3x power. Now, when you graph these, we're going to use our calculator. I'm going to put the first one in because I don't know if you guys have calculators handy. So I'm going to go here. I'm going to go y equals, and I'm going to do 2 parentheses 3 parentheses housetop x. I'm going to go to the table, and I start at negative 2. I will zoom that in just a little bit so you can kind of see it a little bit better. And you can fill in your table. Negative 2 is 0.222. Negative 1 is 0.666. 0 is 2. 1 is 6. And 2 is 18. You're going to graph that down here. Now, b is greater than 1, right? B is 3. So you already know it's growing. You know it starts at 0, 2, which is right there. Over 1, up 6. 2, 18, so it's like up there. So if I were to graph it, and it doesn't have to be perfect. It's going to go here. It's going to come down. I'm going to put my asymptote right here. And you know me, I'm going to highlight it because I love highlighting it. That's my favorite part about exponential functions. I get to use my highlighter. So there we go. Real quick, growing or decaying? It's growing. So if you want to put a note on there that it's growing. The domain, all real numbers. The range, the y value is always up here, so the domain or the range is y is always bigger than 0. You could put those on there if you just wanted to have some extra notes. All right, so here we go. Y equals, I'm going to insert a negative. It's the same equation. There we go. We're going to put those in. And you might notice it's the exact same thing. It just has negatives. So just copy those over. Negative 0.222, negative 0.666, negative 2, negative 6, and negative 18. All right. I'm going to graph it. We can just see it. Oh, look, there it is. There it goes down. All right. So again, there's nothing here. It's like plus 0, so that means the asymptote is right here at 0. I didn't do that on the other one, but you could see it's plus 0 over there as well, if you just wanted to write it. Alright, so there's that. My intercept is at -2, and then we go over 1 and down -6. So it's going like that, and it's going back this way. Is this growing or decaying? Yeah, that one's growing too. It's growing negatively. So you might make a note that this is growing negatively. This one's growing positively. Okay, so there's those couple of ones. The other thing we need to do is we need to write these exponential functions. Now we did these, trying to remember if we've done those in my class. I think we have, but just in case we haven't, I'll just walk you through. So in this, oh yeah, we have done these. Okay, so if I give you the point 0, 2 and the point 1, 6, and I tell you to write the exponential function that goes through those 2 points. What I like to do, what's the easiest thing to do, is just set up a table, 0, 2, and 1, 6. I only need 2 points, and it already told me that they're exponential. So we're going to go to our calculator, or if you're using the emulator, you can use that too. We're going to go to Stat. Let's put that on here. We're going to go to Stat, Edit. Okay, so on here I'm going to go to Stat. And when this comes up, I'm going to hit Enter for Edit. Now, if you have numbers down here in your calculator, you're going to go up to the top where it says L1, hit Clear, and then move back down. Up to the top of L2, hit Clear, and then move down. If you accidentally do this, if you accidentally delete that, oh, where did L1 go? You do this. Go to Stat, and go to Setup Editor, hit Enter, one more time, and it says done. And now when you go back to Stat, Edit, your L1 will be back. So rewind that if you need to. Okay, so here we go. 0, enter, 1, enter, 2, enter, 6. I've got my points in there. Now I'm going to go back to Stat. I'm going to write this on here so you know. We're going to go back to Stat. And this time we're going to do Calculate. Stat, Calculate. Okay, I got other people in here too. And then we're going to go down to 0. They're getting noisy. To 0. Hit Enter. And you're just going to hit Enter all the way through. Bam, there it is. Y equals A is 2, B is 3 to the X power. Okay, so that's how you find it using your calculator. Now, I know down here it says calculator, but we're going to do something different down here. So it was super easy to do that. It wasn't very hard. Stat, edit, stat, calculate, 0, bam, got it. What if this were this? If I had 0, -2, and 1, -6. Prepare to be amazed. Here we go. So we're going to go back to Stat, Edit, and we're just going to change this to -2 and this to -6. All right, so here we go. Let's go to Stat. Some of you have already pushed your button and you're like, oh, what happened? 0, exponential regression. Oh, it didn't work. Here's what happened. When you have a graph of an exponential function that's up here in quadrant 1 and 2, it works. In quadrant 3 and 4, when the A value is negative, you can't do the regression. So here's what you have to do, because sometimes this might happen, most of the time it won't, but just in case it did. You have to look and say, okay, y equals AB to the X power. Can I look at that and see the A value? And I can. The A is right here. It's the y-intercept. The A is -2. But what is B? I can't see B, and I only have 2 points. Remember, the B is the, ooh, flying markers. The B is the y values. It's the common ratio. So it's going to be -6 divided by -2, which is a +3. You just have to take the y values, divide them out. Be sure you take the second point and then the first point. So y equals -2 times 3 to the x power. Okay? And if I were to plug it in, I would see those points on there. So when a is negative, you can't do the exponential regression. All right, how are we doing on time? We're doing good. All right, so let's look at our growth and decay. So here you go. F of x equals a times 1 plus r to the x power. Now, those of you in my class know I don't really follow this right here. I just say, you know what? Let's just do a growth. ab to the x power. I'm just going to ab to the x power, and I'm just going to know that it's growing. So here's what I've got. A is going to still be my starting amount. So on these, you're going to have things like, oh, I go out and I buy a car for $50,000. That's the starting amount of the car. I buy a house for $250,000. That's the starting amount of the house. But you're also going to have a percent. That percent's going to be R. R is going to be the rate that it's either growing or decaying at, what it's increasing at or decreasing at. So we're going to call this the growth percentage. And so maybe a better way to look at this one is f of x equals a times r to the x power. But r has to be a percent, and we have to look at it as if we start every problem with 100%. So you're like, oh, okay, I'm not sure I follow. When you're going to do your r, you have to take 100. You have 100% of something, and you're either going to increase that or you're going to decrease it. So let's say I am doing a growth. That means I'm increasing. So let's say that r would be growing, so I would be getting bigger. I'm going to add. Over here on the other side, when I do decaying, guess what? It's going to be 100 minus. So we're going to say 100 plus whatever the rate is, 10%, 3%, 0.2%, whatever it happens to be. And then this is going to give me my growth percentage. And what I'm going to have to do with the percentage is I'm going to have to change it to a decimal. Okay, so let me do an example down here. Let's do an example. Let's say that r equals 3%. Okay, and we want to solve this problem with this. So we're going to do 100 plus r, which is 3%, which is 103%. Okay, 103% growth. So if you're growing by 3%, then it's 103%. You can't put that into your problem, so you have to move it over 2 places. So that would be 1.03 for my rate that I'm going to plug into my problem and solve. All right. When you're doing exponential growth, think of this just as it's more than 1. That means it's growing. So if you had 1.13, that's more than 1. If you had 1.002, that's more than 1. That's growing. If you had 1.40, that's more than 1. So now what I want to do is go the other way. Tell me, what rate of growth excuse me, is 1.13? How much over $1 is that? 13. So that means that this one was a 13% growth. How much over $1 is this? You got to be careful. Think about it. We had this one, you kind of moved it back 2 when you saw it was 13. If you move this one back 1, 2, this would be 0.2% growth. That one's a little tricky. This one, we're 40 over, so this would be a 40% growth. We're going to do more of those if you didn't quite follow that. Let's do one more. Let's do 1.08. How much over $1 is that? 8 pennies. Move the decimal back 1, 2. So it would be right here after the 8. So that's going to be 8%. percent growth. Think about it, it's the reverse. You're going from this over to that. Okay, so let's go over here and let's do decay. Decay is going to be the same thing. A is going to be the starting amount. And R is going to be the percent of decay. We're still going to kind of look at it as f of x equals a times r to the x power. And so we're going to do 100, because it's decaying, minus r will equal the decay percentage. So, and we're going to have to change that to a decimal. All right, so let's do another example. Let's do R equals 3% again, but this time let's do decay. So that means I'm going to be less than 100% because I'm decaying away. I'm going to do 100% minus 3%. 100 minus 3 is 97%. I can't keep that, so I have to convert that to a decimal. So I'm going to move it over 2, and that'll be 0.97. See how this was more than 1 and this is less than 1? When you decay, you will be less than 1 every time. Less than $1 is probably the easier way to think about it. Okay, so let's do some examples. Let's do 0.95. Let's do 0.85. Let's do 0.72 and maybe 0.01. So remember, these are all from 100. So 100 minus what would give me 95? So maybe it would be helpful to do it this way. 100 minus 95 is 5. So that means this was a 5% decay. 100 minus 85 means this was a 15% decay. 100 minus 72 means that this was a 28% decay. 100 minus 0.01 means this was a 99.99% decay. Oh, did I do that right? Yeah, 99.99% decay. Like everything went away on that one, like it lost it all. That one's kind of a different one. All right, if this would have been 0.99, then it would have been a 0.01% decay. This is a huge, this means that that's like all you're left with each time. That's bad. That's very bad. Okay, here we go. So in January, a clothing store earned $175,000. Since then, earnings have increased. So whenever you're doing these exponential growth or decay, always look for the keywords. Increased. The one below it says decreasing. Over here, I see increasing. And down here, I see depreciates. If something depreciates, it loses its value. All right, so here we go. We're going to think about y equals AB to the x power. How much am I starting with? The store earned $175,000. Since then, they've increased by 10%. Oh, I'm increasing. So that means I'm increasing by 10. That's 110. Change that to a decimal. So that's 1.10. So that means over here, my rate is going to be 1.10 to the x power. Yay, I wrote my first equation. Okay, they want me to predict the earnings after 9 months. So that means I'm going to evaluate y equals $175,000 times 1.10 to the 9th power, the 9th month. Okay, I've already done these in my calculator. If you have a calculator, you can do it as well. It is money. So I want to make sure I put a $sign. I will do this first one. $175,000 times 1.10 housetop N, and there it is. So I'm going to write it on here. $412,640.85. All right. Where am I at on my time? 25 minutes. We're doing good. Okay, let's just go down and do the next one. The population of a town is 2,500, and it's decreasing. Well, if it's decreasing, I'm still doing y equals ab to the x power, but I'm losing 3%. So that means I start with 100%. You always start at 100, but you're decreasing and losing 3%. So 100 minus 3 is 97. Move that decimal over. So that's 0.97% each year. That's all you're going to recover. So y equals the starting amount, which is 2,500 people. We're only going to keep 97% to the x power. What's the population after 8 years? All right, I'm going to let you do that. You plug it into your calculator. Here's what I got. 1,959.35 people. Yay, only 1,959.35 people. You agree with that? No, don't agree with me. Okay, you can't have 0.35 people, right? So are we going to round up or down? 0.35, not even half, so we're going to round down. So my answer would be 1,959 people. Be very careful when you are working with application problems. Pay attention to what you're finding. You can't have 0.35 of a person. All right, here we go. So the population of a school of 800 students is increasing at a rate of 2% per year. So here we go. So y equals ab to the x power. It's increasing, so that's 100 plus something. I'm increasing at 2%. So that's 102. Move that decimal over. So that's 1.02. So y equals the starting amount, which is 800 students. Ooh, students. I better be careful. Can't have half a person. 1.02 to the x power. So y equals 800 times 1.02. I want year 6. I'm going to give you a second to do that one. All right, 900.929. I can't have 0.9 of a person, but that's almost a whole person, right? So let's say 901 people or students. All right, last one, the new car. You know they lose value the second you drop them off the lot. Here we go. A new car depreciates. So the rule is y equals ab to the x power. Y equals the starting amount. The general rule is that the car loses 15%, so that's 100 minus 15, which is 85. Turn that into a decimal. That's 0.85. So 0.85 to the x power. How much will the car be worth in year 10? So 25,000 times 0.85 to the 10th power. I don't think my car is going to be worth very much. Here's what I got. It's money, so I want to put a little dollar sign. 4,000. Oh, that's painful. My $25,000 car. $4,921.86. All right, y'all. I hope that helps you as you move on into your iExcel or whatever else you might be working on today. Thanks for watching. Y'all have a great day.